Dr. Said. So I'm sorry if I cannot follow you until the end of this webinar because I have also some another meeting. But I think that Dr. Irma will coordinate this event until finish. And thank you for sharing. And I hope you can also increase some perspective, new perspective value for us, and also some. I hope also some next collaboration with your country. I think it's possible.
Sure, sure. That will be
Understand.
great. Thank you so much for the invitation. And yeah,
Welcome. Yeah.
it will be honor for me again.
Yes.
Thank you.
Thank you. Ya. Ya, silakan Bu Ima. Terima kasih sekali lagi. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak Kapus atas pembukaannya. Okay, good morning, distinguished guests, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Very warm welcome to everyone joining us today. On behalf of the Inland Water Pollution Dynamic and Ekoremediasi Research Groups, I would like to welcome all participants to PRLSDA Webinar Series 4. We are very happy to have, I see the participants from Paris Institution join us for today's webinars. And today's topic address one of the most promising environmental challenges in Southeast Asia, the sustainable treatment of palm oil milk effluent or POMET, as the palm oil industry continues to expand, developing efficient environmental friendly wastewater treatment technology has become increasingly important. Innovative approach that integrate biological process with advanced membrane technology not only improve wastewater treatment efficiency, but also promote resource recovery and contribute to the circular economy, of course. We are therefore honored to host today's presentation on this exciting result. This is now my great pleasure to introduce our distinguished speaker. Today, we are honored to welcome Dr. Syed Saquib, is right? Okay. An accomplished researcher whose work focus on membrane technology, algal biotechnology, wastewater treatment, and sustainable environment engineering. Today, Dr. Syed will deliver a presentation with the title Hybrid Algal Membrane Photobioreactor for Sustainable Palm Oil Mill Effluents, Valorization, and Biomass Recovery. In this presentation, he will discuss the development of innovative hybrid algal membrane photobioreactor system for treating high-strength palm oil mill effluents, how strategy to mitigate membrane fouling, biomass recovery, and of course the potential application for this technology for sustainable wastewater management. But before we start the presentation, let me show the biography of the speaker. Okay. Okay, browser the tab. Where is? Oh, okay. I can share, but maybe I will curate. Okay. Wait. Where is the? Okay. Dr. said he get the Doctor of Philosophy from Bandung Institute of Technology in 2021 to 2024 and get Master of Science in India and Bachelor of Science in India too in Mahatma Gandhi 𝐥𝐤𝐭 and he work experience he ever to graduate teaching assistant in IT Bandung Institute of Technology. So he get project insurance, the Energy and Resource Institute International in German. Organization skill, he have skill in technical and laboratory skill. And so many conference seminar he will attend and the publications he have also many publications too in the high quality of journal of course. Okay, Dr. said without further ado, I would like to invite you to begin this presentation. Dr. said time is yours.
Thank you so much, Irma. Dr. Irma, let me share my slides.
Pak Yoga, tolong di mute kali Pak Yoga ya.
Yeah. Is it, am I audible, clear as well as my slides are on the view or not? Okay. Assalamualaikum warahmatullahi wabarakatuh. To all of you, good morning. To all the participants and the host and organizers, Dr. Luki, especially Dr. Luki, Dr. Irma, and other distinguished participant of this webinar series number 4. So, as my introduction already done by Dr. Irma very nicely, so I'm thankful to her. And so directly going toward the presentation itself. So today's webinar series or the webinar presentation will be based on my current work that I done and still I'm doing in the PRLSDA-BRIN GB now, which is based on the hybrid or integrated algal membrane photobioreactor with other sustainable technologies for the overall palm oil mill effluent valorization and biomass recovery, as well as the treatment of palm oil mill effluent under the permissible limit on the global scale, as well as the Indonesian standards. I would like to thank Dr. Lina Satya, my mentor, to give me opportunity to work here, and all the other my team members, as well as who are working with me, and also our collaborators from 𝐥𝐢𝐬𝐭, ITB, Sri Technology Bandung, which is my alma mater, 𝐥𝐢𝐬𝐭 and Kobe University, based on the SATRE project, which I am working on. This is the overall presentation outline, starting with the introduction. What are the objectives and problem statements regarding this issue of palm oil mill, and material methodology used in the research till now, and result discussion and conclusion. So as we know that palm oil is one of the highest using or the generated as well as the usable commodity, and the type of oil or the edible oil which is used globally. Around like 80% of the oil market is captured by the palm oil itself. But on the other hand, the problem with the palm oil is the generation of the very high and burdensome effluent that we called as POME or palm oil mill effluent, because it contributed toward the environmental burden regarding waste stream generated in specifically from the agro-industrial sector, particularly and especially in the Southeast Asia. And Indonesia is the highest contributor toward the palm oil production and the effluent production itself. The problem with the palm oil mill effluent is that it is characterized by very high organic and inorganic loads. The coloration is too dark, which is not compatible to be thrown or directly into the environmental system. As well as strong odor, it is rich in suspended solid, dissolved solid, oil and grease, and other nitrogenous, phosphoratic, and other pollutants, recalcitrant pollutants. As I said, that palm oil is a real gold for the Southeast Asia and other global perspective, but the problem is with its effluent that is generated at a very significantly high amount. If we see the characteristic of palm itself, the COD and the BOD level is too much high, which ranges up to 15,000 to 100,000 mg per liter ppm of COD, above 50,000 above BOD level. TSS itself around 50 to 60,000. Oil and grease around 130 to 18,000 mg per liter. And the direct stream of this effluent contributed toward the very high extreme temperature, which is around 80 to 90 degrees Celsius. So it need to be rested before the treatment. And the pH is around between 3.5 to 6 or 5, around 5 or 6, which is acidic in nature. So we need to treat this effluent or the waste stream before throwing it in the environment itself. There are several conventional technologies that are used till now for the treatment of industrial wastewater, specifically in palm oil and other types of agro-industrial wastewater, namely adsorption, sedimentation, coagulation, population, and exchange, open ponds or aeration lagoon also, and other kind of conventional membrane and other technology and activated sludge itself. But the problem with these conventional technologies are that they have the operational and maintenance cost of such technologies are much more higher. They generate a significant amount of sludge and suspended particle itself in their regime, and to operate these conventional technologies, we need a significantly higher amount of energy And also sometimes we need to use certain chemicals that itself become a burdensome toward the environment. So the question is which kind or what kind of technologies that need to be implemented to treat such wastewater or waste before in the environment itself, before throwing in the environment. So we need such technology or innovative technology that has low operational and maintenance cost itself. It is sustainable in the energy consumption, in the techno-economic value, as well as the produces low chemicals, or the effluent should be very treatable, which can be considered under the permissible limit of the national and international standards, as well as there must be no or very low chemical usage. It's good if there is no chemical usage. So in our current research, we considered the membrane photobioreactors, and specifically in the membrane system, we took the hollow fiber membrane. The reason to choose the hollow fiber membrane or the membrane technology is because of the low sludge production, as well as high efficiency toward the pollutant treatment, and the energy consumption is much more lower in comparison to other conventional technologies, and the low capital and capital cost and low maintenance, as I told. As the membrane technology we're using, we are also considering the algae as for biomass recovery, as well as the overall pollutant reduction. We choose the Spirulina platensis currently as our algal species or algal microalgae. The reason to choose Spirulina in comparison to other unicellular or other common microalgae is because they have high tolerance toward the environmental factor like pH, organics, and other pollutant in comparison to other common microalgae like Chlorella, Acinidesmus, and others. Nutrient removal efficiency is excellent, specifically for nitrogenous and phosphorus-based pollutant. The biomass harvesting or recovery is much more easier in comparison to other and much more significantly higher. The value of biomass that recovered is much more significant and much more higher in comparison to other ones, because we could use it as if we got the very high quality biomass after filtration or something, some other filtration technologies, we could able to use it as a feed in pharmaceuticals, in fuel, like a biofuel or other kind of value-added products. If we consider it as a CO2 capture or CO2 carbon dioxide sequestration technology, this Spirulina has a greater tendency or efficiency, and also the utilization and light utilization and growth rate is much more efficiently higher in comparison to others. So going to the objectives of these studies, the first objective or aim was to development and optimization of algal-based hollow fiber membrane photobioreactor that we called AHF-MPB or HFS-MPB because it's a merged type of membrane module. We need to treat the high strength PROME that is directly like from the industry, a real PROME wastewater. Investigation of fouling on the bioreactor performance that is right now we are considering right now. And a headline modeling of dominant fouling mechanism also that will be ahead, not yet done. But it is the objective, one of the objectives. And also to implement some fouling mitigation approaches specifically based on the operational optimization, physical, chemical, less chemical cleaning, but physical cleaning, as well as a biological approach like 𝐸𝐴𝐴 quenching that will be considered ahead. And the techno-economic assessment at the last overall in the studies. The novelty of this research is that we propose the algal hollow fiber module, the kind of hybrid kind of, which is reportedly very few reported studies were done. Although there are significant studies, but it is not too much explored till now. Fouling analysis we are doing, also the filtration test, fouling analysis, and dominant fouling mechanism that has to be considered ahead, and fouling control by the novel approaches like 𝐸𝐴𝐴 quenching, and biological and physical and operational parameters based fouling control in the membrane system itself. And the techno-economic assessment, that is one of the objectives for it. Common methodologies which are done for the chemical and other for the other analysis were done, like we done the total phosphorus, nitrogen, ammonia, nitrate also, chlorophyll, A, lipid, beta carotene, other biomass constituents analysis, COD, BOD, and color analysis also, as well as not yet done microbial community, but we will do it later stages. SEM and EDX already done with the FTIR analysis. So moving toward the first major study that already done, and which is based on the high strength POME treatment and bioresource recovery in an integrated membrane photobioreactor with granular activated carbon column for the overall POME treatment as well as bioresource recovery or biomass recovery. This is the semi-continuous small-scale photobioreactor, membrane photobioreactor integrated with the GAC column, granular activated carbon column, that we propose the name like MEMBER, which stands for Membrane Biologically Electroactive Reactor, where the GAC, that granular activated carbon, is electroactive in nature because it has certain microorganisms which are potential for the electroactive electron transfer and enhance the redox reaction and overall pollution reduction based on the physical as well as the chemical quality. This is the illustrated diagram. This is a real setup that we put in our culture lab, although it's small scale, but it is highly significant result that we got. The operational condition were like this. The total working volume for this member reactor system were 575 ml, where 400 ml for the membrane photobioreactor and 175 ml for the GAC column. We use the real pomade taken from the industry, pomade industry. The operational days were of around 2 months, around 61 days, and the membrane area were 0.0135 because it is small scale reactor. Total HRD, it is semi-continuous in operational mode of around 14.37 hours. And the flux was a bit lower, or the median around 3 LMH. And the aeration, we give 5 liter per minute of aeration. Moving to the results, these are the results that we got, which is very significant and very good from the very beginning of the results of the operational days. We found that around 99.04% of COD, carbon dioxide, chemical oxygen demand removal, and if you see. Okay, if we see that the membrane system, the MBBR system was contributed toward the 80% of 70 to 80% of the COD removal, which were enhanced by around 10 to 15% by the GAC column itself, by the electroactive, the regime and the filtration system, and the partial adsorption system that majorly by the electroactive microbial activity. And we reaches almost 100%, like it is almost like maintain around 99 to 100% of the COD removal. If we talk about the total nitrogen in removal in the MPBR system was although lower in the beginning, but it is significantly increased and reaches up to 60%. And by the GAC column, it enhanced until the almost 90%, which is around 85 to 83% of the total nitrogen removal. Similar result we got for the phosphorus removal also. And we got like in MPBR around 50 to 60% of the total phosphorus removal, and which enhanced by the GAC column until the 85, above 80%, 85%. And the mean removal, GP removal was around 84.01%. If we talk about the pH and DO concentration, it was under the general value, which is a favorable value to favor the algal growth inside the membrane photobioreactor, which was around 9 to 10. And also in the activated carbon around DO was 8.62, which was like median one. And the pH was also the neutral, around neutral. This is a very good result. If you see that this is the original POME, like after filtration, after the initial filtration, we use the filtered POME wastewater, and you could see that it is highly colored wastewater. It could not be thrown inside, or could not be directly put in the environment itself like this. Even the aesthetically, it is not feasible or not good. After the treatment in the MPBR system, and the permeate is like this, where the significant reduction of the color taken color we could see here. And when the MPBR permeate goes to the activated carbon column, granular activated carbon column, we got and the effluent, the final effluent, we got like this, which is almost devoid of any color. So we got a very high physical and chemical pollutant reduction from this hybrid technology in the member system. If we talk about the algal biomass production and the following constituents and characteristic, you could see the optical density increase from day 0 to day 60 or 61 around reaches around 0.08, and the specific growth rate per day was around 2.04, and the average productivity in mg per liter reaches around average was around 60.85 plus minus 2.57 mg per liter per day, and the doubling time for the algae, the Aspergillus platensis, was around 2.1, which shows that high biomass growth. Other microalgal biomolecules, if we talk about this, the biomass concentration itself reaches around 160 gram per liter. Which was around 7 gram per liter, 6 to 7 gram per liter by the end of this operation or this study. And the biomass productivity reaches like average 68.85 mg per liter per day. For photosynthetic pigment, that is chlorophyll A and beta, or the total carotene, not exactly beta carotene. Total carotene is around for the photosynthetic pigment, that is chlorophyll A, the average or mean value was around 1.5 to 2 percentage of dry weight, and the total carotene around 1 percentage of dry weight. Phycobilly proteins like phycocyanine, allophycocyanine, and phycoerythrin were also significant in amount and concentration, with around 9 or 10% of dry weight, and 4.5 around 5 to 6%, and for APC and for PP, that is phycoerythrin, was around 2 to 3 percentage of dry weight. Macromolecules like protein, carbohydrate, and lipid were also significant in concentration, and by the end of the day, we already got the protein concentration of around 70 percentage of dry weight, and with the mean percentage dry weight of protein around 45 to 50%. Carbohydrate around 10%, and also lipid was around 10% of the dry weight percentage. So overall, the biomass or biomolecule concentration or the generation was also significantly higher in such system, where we optimized the operation, as well as provided us a membrane system which retained the biomass itself in our system, and we could able to harness that biomass and filter it for the byproducts if we could go ahead with this results. We done the FTIR spectral analysis for hollow fiber membrane for before usage and after this for pristine and used hollow fiber membrane, as well as for our GAC, activated carbon, before and after usage, to see what are the constituted changes itself in our system, or in our membrane system, as well as our media, that is a GAC. So by the result, we could see that there is highly significant increase, or the increase in the bending of or the peak for the OH, NH, the hydroxyl NH, as well as other like aliphatic and aromatic compounds also seen in from before to after, which shows that the retention of the byproducts, or the dissociated products from the POME itself retain on the membrane surface, and membrane itself hold down, use as a signal filtration system for in this study. And for GAC also, the presence of these aliphatic aromatic carbon bond, or carbon hydrogen carboxyl bond, hydroxyl bonds, or in the peak of the bendings, shows that there were significant absorption, or the as well as which adsorption of the pollutant, and which were followed or the enhanced by the electroactive microbial activity for the redox reactions and the total pollutant reduction. From the SEM and EDX analysis, here is the SEM images. For figure 7 shows SEM image for the hollow fiber membrane before and after usage, and as well as for figure 8 shows the surface morphology for pristine and the used 𝐥𝐤𝐬𝐭 media. If we see that the figure A, B, and C, 7A, B, and C, it is for the pristine membrane. It is devoid of any external accumulant on the surface as well as on the transfer section. And if we compare it with the D, E, and F, which were after the usage of the membrane system after 60 days, you could see that there was not that much of changes taken place. So it resulted that there was not that much falling happened on the membrane system itself. In such aeratants are like aeration itself help for the solvent mitigation or solvent reduction on the membrane surface, and which was evident or supported by the surface morphology, where you could see that before and after images of the surface morphology of the hollow fiber membrane, there is significant pores are still visible. And on the surface itself, we could see that there was a accumulation or the presence of several algal bacterial or algal microbial constituents like Spirulina platensis, as well as globular structure shows that there were several bacterials, the symbiotic bacteria also taken place on the surface, which helps in the overall pollutant treatment. If we see for the surface morphology or by the SEM images for the 𝐥𝐤𝐬𝐭 media, this A, B, and C, figure 8, A, B, and C shows for the before the usage, like the pristine or the raw or the new 𝐥𝐤𝐬 media. There is significant pores or porous structure we could see here, which were also maintained by after the usage. So still there was a significant pore still present there. And also here, but we could see that accumulation of several organic and inorganic pollutant or the accumulates also present or the trapped by the 𝐥𝐤𝐬 media to enhance the water quality or effluent quality, the final effluent quality. There were some more results in this that are not showed here, like EDX analysis as well as, but these are the significant studies done in this study 1. Second study was based on the results we got from the study 1, and we enhanced we scale up our reactor, and it is not semiconductor but continuous in the operation, and the study is based on continuous hollow fiber submerged membrane photobioreactor for POMA treatment and bioresource recovery in semi-outdoor condition. Earlier it was in the indoor condition with the artificial lighting condition, but here we give the semi-outdoor condition in our greenhouse. Here. This is the overall schematic or illustrative diagram for the 30-liter hollow fiber submerged MDBR, and we use the PVDF hollow fiber membrane here also with pore size of 0.01 mm, outer diameter of 1.44 millimeter, and inner diameter of around 0.9 millimeter. This is a real setup that is still working on an ongoing study in our greenhouse. So these are the operational conditions or the parameters. The total working volume for this study that is ongoing is around 30 liter. And the wastewater type, again, we use the same real filtered POMA. Operation duration is still ongoing. It's already like around 2 months of the study, like after the acclimatization, and the membrane area of around 0.20 meters square. Total charity of 3 days, because right now the main study is based on the different initial fluxes, low, median, and higher fluxes, and also the dilution rate. So dilution rate right now is at 0.3, and so the resultant evaporation flux around 3 LMH, and aeration is around 10 L liter per minute in this study. So till now, we got also a very significant COD or another pollutant removal. The COD removal for this around 87.73, an average COD removal of 87.73%. And if we see here, this is in the MPBR system, the filtered after analysis from the MPBR. There is algal removal by the algae inside the reactor itself. Around it is fluctuative, but reaches around this after 1 month around 70 to 80%. But if we see the total removal after the membrane system, like membrane itself filtered it out, and the membrane system, the total removal reaches around 90%, like 87.73. So the membrane system itself retain the biomass as well as treat the POMA pollutants significantly. Other TNTP and TN also we are doing, it is also significantly around above 80%, which is not shown here, but it's also like significant removal. Because we are also considering the flux ratio as well as the normalized flux, operational flux changes. So you could see that the transmembrane pressure was stable around 0.7 to 0.74 bar. And then after the around 400 hours of the manual reading or manual analysis of the flux decrement or flux changes, we could see that from normalized flux of 1, which is like 100% filtration, after it reduces around 60% of flux decline, which is because of the slow but continuous falling of the membrane system, which is still going on. And we will go until the 80% flux decline, and after that we will clean the membrane physically only with water, and we'll see how much flux recovery will take, which is not yet done because still it's not reaches 80% of the flux decline. So it is still the we could conclude that from this flux decline or the normalized flux profile, that even after like very long operation of around more than 2 months, the flux decline is only reaches until 60%, not even 80%. Like that. So the membrane hollow fiber based module based membrane photobioreactor is a very significant technology to retain the biomass, algal biomass, for biomass recovery and bioresource recovery, biomolecules recovery, as well as treatment of such high strength industrial wastewater and industrial wastewater without any burden toward the economic, techno-economic aspect of the operational cost or the maintenance cost of the system itself. If we talk about the biomass, again the biomass recovery or the optical, based on the optical density, we will get the specific growth rate of algal biomass around 2.266 per day, or and average productivity of around 44.5 mg per liter per day, and the doubling time of around 2.61, which is significantly good. In this system, we are doing the real-time monitoring of several parameters like pH, DO, hardness, total dissolved solids temperature, as well as conductivity and resistivity and salinity level. So the till now the pH is maintained around 8 to 10, and also the DO was reaches around, because we are pumping around 10 liter per minute of the aeration. The DO was fluctuating from initial around 3 mg per liter. It reaches around now 10 to around 10, average 10 mg per liter of dissolved oxygen. TDS is significantly higher, or hardness is higher, because of the presence of several organics and organic constituents inside the POMA itself. Because although it is inside the reactor, the effluent we are also considering the final effluent, where the TSS and TDS reduction is significantly higher, and the removal rate is much more higher, and the overall TSS and other hardness reduced in the final effluent. Temperature fluctuated because of the light and dark phases, like because it is in greenhouse, and then exposed toward the natural lighting conditions. So the temperature fluctuates between the 24 to 32 degrees Celsius based on the days. Conductivity also in a median or the significant good range, as well as the resistivity in ohm is also around 15 ohm, which is still fine for the overall system maintenance. If you see the morphological description of this Spirulina platensis from this 30-liter hollow fiber submerged MPBR, this is a very recent result we done this week itself on, and we could see that very high concentration of the healthy spirulina biomass. We will see the Spirulina platensis. We could see by the light microscope at different resolution like 4, 10, 1400. These are the total study till now, which is still going on, and several parameters need to be taken still consideration, as I told in the methodology, and hopefully we'll get a good result ahead also. With this, I would like to conclude. In conclusion, I could say that hollow fiber submerged MPBR when integrated with the integrated with the significant sustainable technology like 𝐥𝐢𝐬𝐭 activated carbon or granular activated carbon gives us a very enhanced true color reduction as well as organic pollutant removal through the partial adsorption and the significant electroactive biodegradation synergistic approach. Spirulina platensis effectively adapted to the POME, that is high strength agro-industrial wastewater, that is considering as POME in our case, and contributing to nutrient removal, oxygen duration, as well as improved effluent quality. Membrane-based continuous operation ensured stable pump permeate quality while controlling suspended solid and other operational fouling and other pollutant. And activated carbon column acted as an efficient polishing unit actually, and improving effluent clarity, quality, and enhancing the treatment performance on the overall perspective. So we have to consider such integrated, sustainable, low-cost technologies based on the biomass, algal biomass, as well as the electroactive and adsorptive approach for which offer low energy scalability, as well as sustainable solution for the large-scale industrial implementation for POME treatment, as well as other agro-industrial and other high-strength recalcitrant pollutants or the wastewater. With this, I would like to thank you all for listening me, and I'm open for the questionnaires if there is any, and with the message that for a cleaner future, our planet needs me, you, and every one of us to come up with an approach that is much more sustainable, easy to implement, and is scalable. The main thing is scalable. Should be scalable and should be in the real approach or real world importance, and as well as the real world approachability and usage, not something just inside the small scale laboratory. It is not feasible at all. Thank you so much.
Okay, thank you very much, Syed, for your excellent and insightful presentations.
Thank you so much.
Okay, ladies and gentlemen, it was very informative session, highlights how the integration of microalgae, membrane technology, and electroactive system can significantly improve the treatment efficiency. Your president has clearly demonstrated the potential of this innovative technology to support sustainable water management. And now, for participants who want to ask for Syed, please raise your hand, or you can use the chat box. I open for the first session for the question, please. Okay, so before we writing the other question, maybe we can see in chat box from Pak Ika. He asks you about what's the best method to keep the balance between bacteria and flow rate so the membrane does not get clogged. Please.
This is very significant actually. The thing that we are right now looking for, what's the best approach? The best approach, the easy one, is the operational parameter. How much, for example, our is like the significant amount of aeration also could, as we see in our result, that aeration itself reduce the fouling on the membrane system, which is an operational parameter, which is easy to implement as well as, and because it is like a aerated system, so because we are considering the real wastewater and there is sludge also in it, so the bacterial regime changes with the operational parameter. So if we provided anaerobic, the anaerobes will like flourish. But in our system, we have to maintain the algae as the main constituent. So we need to symbiotic relation between aerated or aerobic microbes with the our algae, that is spirulina. Till now, we didn't done the morphological community analysis for what kind of aerobes is present with the algae, our algae. But I am pretty sure there are several aerobic species that is symbiotically work for the overall pollutant removal as well as enhance the pollutant degradation by redox reaction itself in the system itself. So like first is aeration, and also see the like hydrodynamics also, because if the aeration is significant, the hydrodynamics also significantly contribute toward the fouling reduction on the overall membrane surface. So these are some of the basic things that operational parameter need to be considered first. After that, yeah, if it's like we got 60% of the flux reduction, I have to go until 80, and then I will see the SEM-TEM analysis again to see what are the how the changes the porosity and other things changes with the time, and what is going behind the curtain, like what is going inside the system itself with the membrane, and how we recover the flux recovery itself again. Like these are the things need to be considered first, and then maybe biological approach like quorum quenching ahead, and we will compare the physical like operational parameter, flux recovery, and other like fouling reduction with the biological approach. I'm not considering chemical that much because chemical will not, because I don't want to make it unsustainable. So that's why chemical approach need to be considered at very last, and at very large scale implementation like real in industrial chemical usage is much more degradative toward the effluent quality in comparison to biological approach. Yeah, that's the thing. I hope I answered well. Paika.
Okay, thank you, Dr. Shad. How, Paika, is clear? Or any questions? I think Paika is good. Okay, the second question for the chat box said it's from Noptianto Prince. He asks you about what is the key scientific novelty of the proposed hybrid algal membrane photobioreactor for sustainable pomade treatment and biomass recovery? Please.
Sorry, key what?
Oh, sorry, bocorin.
Yeah.
Yes, sir, please.
Yes, sorry, key what?
You can see in the chat box from Panofdi, yes, the key scientific novelty of the proposed hybrid algal membrane photobioreactor. Key scientific novelty.
Key scientific novelty.
Yes, key scientific novelty from your research.
So the key scientific novelty is that itself using the hollow fiber membrane. Till now, like there are studies, but not in very deep and detail like I'm doing right. This is one of the things. The waterfall length, what the falling type and falling regime on the system itself, as well as how the membrane bioreactor, such membrane bioreactor, retain the biomass itself, and what the quality of biomass that we get. This is one of the major and the key factors that we saw, or the novelty and usage of, and the approach, the operational approach. What are the easy, although it is easy to implement, but on the prospect toward the result side, it is much more significant. So first is the what kind of membrane and how much membrane you are using, and what are your approach with the operation like parameters. And the third, based on the result, how you changes it. For example, the preliminary result, I didn't got the very clean water, the effluent. That's why I put the this electroactive kind of GAC media, where the symbiotic relation between the electroactive microbes with the partial adsorption on the by the activated carbon column will enhance the water quality based on physical as well as the chemical. So this is the approach which is which is easy to implement even on the large scale, and we get a very good effluent quality as well as biomass recovery in the photobioreactor system, and followed by the integrated easy to or low energy consumption column, GAC columns.
Okay, thank you, shared. How Panopti is clear? Oke, Bapak Ibu, as I informed you before in this webinar, Syed can speak in dual bahasa. Jadi Bapak Ibu kalau ingin bertanya dalam bahasa Indonesia, dipersilahkan. Karena Syed juga bisa insya Allah mengerti, ataupun bisa dalam bahasa Inggris. Baik, mungkin saya lanjutkan. Mungkin untuk yang langsung di peserta partisipan di webinar ini, yang raise hand, mungkin ada yang langsung mau bertanya nih. Sekalian berkenalan dengan Pak Syed. Silakan mungkin. Okay, Said, while waiting for question for the participant, I want to ask you a few questions. The first,
Sure.
considering that the real POME contain a high diverse microbial communities, right? How stable that was the interaction between spirulina plantasis and indigenous microorganism? Did you observe competition, botulism, or SIP microbial community structure during long-term operations?
Till now, we didn't do the microbial community structure analysis so. But the thing is that itself, because it is very not just microbes, but other pollutants is much more higher, which is toxic for the algae itself.
Okay.
So for the 30-liter reactor, acclimatization take like 1.5 months just on this parameter. So because it is like very dark in color, and the algae need to be acclimatized in such a toxic environment. So of course there is some competition also taken place, because earlier it is kept for a very long time. The POME itself in our place, like in our BRIN, in our laboratory. So of course it is closed, and it is anaerobes will be much more higher. So it's even the changes with the anaerobes inside the system with the aerobic condition, it takes some time. And when the anaerobic and aerobic competition already nullified, or maybe the aerobes will be much more higher, maybe the symbiotic relationship much more significantly flourished with our spirulina plantaensis. Then the acclimatization faster. It's like this. I see that for the first few days, like around 1 month or something, it is very slow growth of the biomass. But after that, around next 15 to 20 days, it is like double. So we could conclude from this physical changes that, or from the chemical OD changes, that initially there is a competition between the anaerobic aerobes and the spirulina. When the system shift toward the aerobes, or totally, or maybe at least significantly, 80-90%, they symbiotically enhance the growth for the spirulina itself without any competition. Like whatever the constituent broken down by the spirulina, it goes toward the microbes for their growth, and the like symbiotic relationship taking place, like redox reaction and all these, like this.
Okay.
But hopefully we will do the microbial community structure also. That is one of the that I showed in the methodology also. We'll do it also. That changes from the initial to the final.
Is the POME that used in sterile condition or unsterile?
It is unsterile. We didn't go for the sterile, because our main aim is not to kill the sterility or something. We want to treat the as we are getting from the industry.
Okay.
Or directly, if we implement this, if we have to, as I give the remark at last, that if we want to implement any of the technology, we need to consider the raw or the in place condition of the wastewater or water, especially in the environmental based technologies or environmental based treatment. So we need to consider the raw, because we can't sterile like thousands of meter cube of wastewater every day. So we need to treat that itself. So we need to come up with some certain technology that is sustainable, easy to implement, and give us very good effluent quality and results.
Thank you, Sir. Oke, Bapak Ibu, mungkin ini this is interesting topic, I think. Jika Bapak Ibu ada yang ingin dipertanyakan atau diperjelas dari pernyataan Syed, please raise your hand or anything, write in chat box maybe. Okay. My question again. Is the microalgae biomass you use is safe for consumption, or used in other bioproducts such medicine, cosmetic, or anything, considering they are grown in POME?
Yeah, that's a very, very good question actually, because we didn't know there was the quality of the biomass itself right now. Of course, there is toxicants also there that much hamper the some byproducts that we need to 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 make from it, right? To generate from it. So this is not the main aspect of my study, but it is already in my mind also. If someone wants to go ahead with this research, or even me, we need to maybe filter it out. We need to see what are the uh, biomass retention, like the pollutant retention, heavy metal and other retention that need to be curbed down actually. So till now we didn't see that, but of course, but there must be higher concentration of certain pollutant that need to be. If we need, for example, maybe we could use it for not pharmaceutical, but we could use it for the biofuels. We could use it for the biofuel or such thing which is not hampered or consumed by the human or any kind of life form, but could be used for the other beneficial product like biofuel, or maybe just protein or something like this for the other kind of usage. Yeah, like this.
Okay, and next, I see that is no participant raise hand and no, no check back to chat box. So I ask you again. In your evidence that is your technology can be commercially in industrial wastewater treatment?
Yes, this is the approach. Like we could make a like big reactors itself, and also the second one to integrate it with sustainable polishing unit like DHS or the GACU itself, like GACU, like a big activated carbon columns. And but maybe the consideration of design need to be changed a bit more to reduce the clogging or something if it's like much more higher. But we need to filter it out, the screening of filtration, because I'm used like the filtered pomade, not the raw exactly pomade with sustainable solids, much more. So it needs to be like to reduce the falling as well as on the membrane system, and reduce the clogging on the GAC or other kind of such kind of treatment technology. But it has a very high significant potential toward the implementation toward the high scale industrial usage itself.
How about the economical value? Is it economist than the other technology?
Preliminary analysis, I just done like kind of not exactly, but preliminary analysis. If I compare it with other technology, yes, it is, because based on the efficiency first and based on the usage. For example, other polishing units needed aeration again, mostly aeration again. For example, especially in the textile industry, if we implement such technology. But in this case, we didn't need any of the aeration, external aeration, or something like this, or curbing, or any other screening or something. We retain the microbial and algal biomass itself in the certain specific units that is implemented in this study, and also a higher efficiency of the effluent. Because this kind of technology I used in the textile industry also, real textile wastewater also, as well as the synthetic textile wastewater also earlier in my PhD. So it is a significant result. And that time I've done the technical analysis also. So it is like 50 to 60% much more economical than the other conventional technologies and the technologies that is usable right now in the industry. Yeah.
Yes, I think for the future you need to calculate this, because there is
Yeah.
the keywords, the key technology that can use in industry,
Exactly.
right?
Yeah.
Okay.
This is right.
Okay, ladies and gentlemen, any question? Still, okay. Maybe it's new for the participant, but okay, one question again.
Sure.
For me, sorry, said. Could this hybrid algal membrane system adaptive to for treating the other high-strength industrial wastewater like textile, food processing, or landfill listed, or anything?
Yes, I think yes, it can be. It can be. Because I done
Is the same it is system, or you need any modification, because any wastewater is different characteristic. What do you think about that?
Yeah, actually, it need to be, maybe it need to be, but we need to do some like based on the wastewater itself. What are the pollutant characteristic or the characteristic of the wastewater itself? For example, in textile industry, to reduce the overall, or for example, to dissociate even the intermediates that are formed after the initial dissociation. Because it is much more toxic in nature, the intermediate itself, rather than the full form of the textile dyes. So maybe we could do the mix consortia of the algae that are symbiotic to each other, or not just one, to see that. But we need to first compare with single and then mix. Maybe this can be an approach. And also for the polishing unit, maybe we could go for stages like 2 or 3 stage also, like using down hanging sponge with the mixture of this and all the change. I have this in mind also, maybe later. Maybe again, if I got the opportunity or I've done this research, there is another system future direction is with the overall putting the GAC but inside like a ball or something like a globular, which gives the more aeration, like natural aeration toward the column itself. So enhance the, like, for such industrial based sort of like textile dyes. Yeah. So like slight changes in the configuration. Yeah.
Okay, thank you, Said. Alhamdulillah, we can see other question for the participant, still from Panapjianto. He asks you about how did you distinguish the individual contribution of alga, microorganism, and membrane filtration to the overall 67.63% CO2 removal?
Yeah, so that's very easy. For example, we took the different sample from different. First is effluent, that is we putting in, which is initial or in, and then influence or influent, and then we took the sample from the reactor itself, like the liquid, membrane liquid or leaker, which is devoid of like membrane, like before membrane, which is inside the system, right? And we took that and see the different pollutant removal like COD, BOD, and other also. And which is the contribution by the microorganism, that is algae and the microbe consortia, like symbiotic. And the third one is the after membrane remove that one. And the final effluent is the total removal or the effluent that is contributed by the membrane system itself. So there is a difference between that. Like if it gives the 40% in from the membrane leaker and reaches 80%, the 40% is the contribution by the membrane system, or the biofilm layer also contribute toward it actually. So it's like this. So that's how you distinguish between influent, your algal contribution from the membrane leaker itself, and the final from the membrane after membrane, the final effluent or total. It's like this.
Okay, thank you, Said. How is from your supervisor, Satya. He asks you, in your opinions, how important is it to monitor the quality of biomass produced in this valorization activity?
Yeah, that's very good and significant question, from Dr. Satya, Dr. Lina. Thank you so much, ma'am. So, in my opinion, it based on what is our aim or objective. If it's to produce some product like pharmaceutical or any product like this, which can be consumed by the human, it is very significant to see the quality of the biomass itself. Like, is it toxic in nature or not? But if it's just to treat and also to biomass reduction, or if it's, for example, to make the biofuel, maybe it's not that much. Maybe we need to just cut down the heavy metal or something with if it's too much higher in that, and after filtration, some significant ionic filtration or any other filtration, and then we could able to use it for the biofuel or such commodity based product. So it based on as I already answered this to you, Dr. Irma. Yeah, the last question is like based on the same answer.
Okay.
Yeah,
it's a good. Okay, thank you, Said. How about Lina? Is it clear, or you want to ask any question directly to Mr. Said? Like with Jen, maybe, yeah, for the next session, the internal session. Please.
Yes, I think it's quite right answer. So good luck, Dr. Shed, if you want
Thank you so much.
to continue in the future or in your next activity. So I think you may also to explain here how about the importance of the key quenching, the quenching of the microbial definition in this case. And
Yes.
and also you may explain more about how the way we can contribute in when we try to monitor the quality of biomass. I think for the safety of the biomass to be used in this activity further. So may you can add more your explanation in this case. Okay, thank you, Ibu
Sure.
Irma, and also Dr.
Thank you so much. I'm sure we will do on this work also, like the quality of biomass to be used for some products, byproducts or product ahead, because we get a very good biomass retention and growth rate and the biomolecules as well as ahead for the microbial community analysis also. This is one of the key need to be to evident the symbiotic relation or the competition, whatever is there. We need to, yeah, this has to be done. Thank you so much.
Okay, Said. Okay. Any participant? Any question here? Or this enough? Okay, the last question for me maybe.
Sure.
Okay, in the future, what is the next step on your research? Are you planning to integrate your research with like artificial intelligence or maybe real-time monitoring for process optimizations?
Yeah, data monitoring based on the process. First is to check the what's called dominant falling types, and how to reduce it with the ahead for biological entity, that is the quorum quenching ahead. That is one of the challenging, but it's still very, very innovative way to reduce the falling without reducing the water quality and the membrane quality itself, which can be reduced by the chemical cleaning actually. And also the microbial community analysis and the symbiotism or the competitive entity with the competitiveness with the our algal species. Also to check other algal species which is available with us to see their working also in such system. And also, as I told, to change a bit of the design for the polishing unit to make it much more efficient and much more working in the large scale system. These are some of the work that we will do ahead.
Oke, smart.
Thank you.
Oke, Bapak Ibu, ada pesan dari sponsor untuk pengisian penerbitan sertifikat webinar karena kita sudah ada di ujung webinar. Mungkin Bapak Ibu silakan dengan segera mengisi formulir yang sudah disediakan oleh Ibu Anissa Indah Pratiwi karena ini dibutuhkan buat keperluan sertifikat. Baik, Bapak Ibu, mungkin terakhir saya kembali menawarkan any question atau ada sesuatu yang ingin dikonfirmasi atau didiskusikan dengan Syed terkait riset beliau tentang mikroalgae dalam proses treatment POME sambil menunggu teman-teman mungkin mengisi. No, is it not? Okay. Okay, Said, maybe it's the end of our webinar today. Thank you very much for your outstanding and insightful presentations. Let me make some conclusion. Okay, today's webinar has highlight innovation approach to addressing one of the most challenging environmental issues associated with palm oil industry, of course, through the integration of microalgae, membrane technology, and active carbon. The Syed Saquib team result demonstrate that wastewater treatment can go beyond pollution control by enabling resource recovery, biomass production, and the development of more sustainable and circular treatment system. We have learned that the hybrid algae membrane photobioreactor not only achieve impressive removal efficiency for organic pollution and nutrient, but also provide valuable insight into membrane falling control, reactor automation, and the potential for future large-scale implementation, of course. This work represents an important step toward developing environmental friendly and energy efficient wastewater treatment technology. Okay, I would like to thank all participants for your participation, insightful question, and enthusiasm throughout this webinar. We have today's session has provided new perspective and inspired future collaboration in sustainable wastewater treatment, environmental biotechnology, and of course, water resource management. like Pak Luki say before, seperti Pak Luki bilang bahwa beliau tidak bisa menutup acara ini. On behalf of the Research Center for Limnologi and Water Resource BRIN, thank you once again for joining us today. We look forward to welcoming you to our next PRLSDA webinar series. Thank you very much. Stay safe, stay healthy, and have a wonderful day. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.